Okay, in this presentation we're going to look at conditional probability and probability questions in general. Okay, so a firm runs a competition advertised in three daily newspapers, A, B and C. So these are the names of our newspapers, okay, which have large readerships in the proportions 2 to 3 to 1. Now, this actually, respectively, this gives us the probability of each of the readership, the proportion of readerships. So 2 to 3 to 1, that adds up to 6. So 2 in every 6 people read A, that's 1/3. 3 in every 6 people read newspaper B, that's 1/2. And 1 in every 6 people read newspaper C, so that is 1/6. So we'll come back to that later on, but that is how we would generate the probabilities of reading each newspaper. So just for the sake of simplicity, each reader reads only one newspaper. Okay. Now, the proportions of the readerships of A, B, and C who enter the competition are 0.02, 0.01, and 0.05 respectively. Okay. So these are the conditional probabilities that we'll use later on. So anyway, so that's the probability of entry to the competition. Now, you may assume that all of the entries to the competition are correct, okay, that it's very easy, and if drawn, would receive a prize. So all entries are likely to be drawn. Okay, so what are the probabilities that the top prize is drawn by a reader of newspaper A, B, and C, respectively? Okay, so let's just get a few things sorted out first off. Now, this is the probabilities of reading each newspaper from this readership, okay? So this is just the aggregate readership of the three newspapers. So, and this is the conditional probability of entering the competition given that you have entered, or that you read a particular newspaper. So, just to remark, this was generated, these probabilities over here were generated from the ratio, just to be clear about what I just sort of said there a moment ago. So let E be the entry that an entry is made. Now I've actually sort of introduced that already, but just to go over it again, the probability of E is the probability of E and A, that you enter the competition and you read newspaper A. Okay, and when we use the conditional probability formula, we can actually re-express it as follows: probability of E given A times the probability of A. And also for newspapers B and C, also probability of E given B times the probability of B plus the probability of E given C times the probability of C. Okay, so hopefully you'll be reasonably familiar with the rationale of what I'm doing here. So I just actually, because this is a longer question, I have talked about the rationale of what I'm doing here in other presentations where it was a bit shorter. This is a longer question. So anyway, when we multiply it out, it is 0.02 times 1/3 plus 0.01 times 1/2 plus 0.05 times 1/6. So essentially just a bit of number crunching there, and we should end up with an answer of 0.02. So of the overall readership of the three newspapers, the amount of people, the proportion of people who are entered the competition is 2%. Okay? So, since all of the new entries are correct, the probabilities of winning is A given E, B given E, and C given E, respectively, for each newspapers. Okay? This is the question we're particularly asked. Okay? Now, just as a remark, I sort of put it in here just to sort of highlight a few things that we're using. Now, I've introduced some of this stuff before, particularly the conditional probability. I just mentioned it there previously. But just to explicitly state that these are the two key formulas that we're using for this presentation. But anyway, what we're asked to do here to answer this question is probability of A given E, probability of B given E, and probability of C given E. Now, I have it here written for A given E, but the same thing can be said for B and C. So what we've just done there previously is calculated that, because we have these already from, we were told these in the question, we needed the probability of E overall, and now what we can do is in each of the three cases calculate the probability of A given E, B given E, and C given E. So essentially what we're going to do here is rearrange this formula here, or this expression here, in each of the three cases A, B, and C. Okay, so essentially what we're going to do essentially is divide both sides by the probability of E. So essentially bring P under the fraction here. Okay, now 0.02 times 1/3 divided by 0.02, that means it's 1/3. Okay, so of the entries of the people who have entered the competition, 1/3 are from newspaper A. Probability of B given E, that means the probability of a winner from newspaper B winning the competition, given that they've entered, is the probability of E given B times the probability of B over the probability of E. Okay, so this is 0.01 times 1/2 divided by 0.02. So this is actually, just remember, we actually have 1/3 of our readership is from newspaper A. Okay, so it's just this number here is coincidental. The probability of the readership from newspaper B is 1/2, but only 1/4 of the entries are from newspaper B. Okay, so that what I'm sort of saying there is that just watch out that this 1/3 and this 1/3, just watch out because they're not the same thing. They don't mean the same thing. They're not referencing the same thing. It's just a coincidence. Okay, and that means like there's just probability of C given E is 5/12. Okay, so it doesn't have a big readership, but they love entering competitions. Okay, the newspaper C. So essentially, even though that newspaper C has the lowest readership, it actually has a high proportion of people who enter competitions. That means that there's a high chance that there is a reader of newspaper C enters this competition. I'm going to stop this video here and pick up shortly on the second half of this video because it's going on very long.